In this video, we are going to continue practicing word problems with conversion factors. Now we are going to be doing what are called clinical problems, or in other words, dosage problems. With these type of word problems, we are going to see how healthcare professionals are going to be calculating the amount of medication that they need to give a patient. Let's see the first example. It reads, Greg has been diagnosed with diminished thyroid function. His doctor prescribes a dosage of 0.150 milligrams of Synthroid to be taken once a day. If tablets in stock are 75 micrograms of Synthroid, how many tablets are required to provide the prescribed medication? So even though there's a lot of words in this problem, let's establish what is the information given. We have a medication. The name of the medication is Synthroid. So that I'm going to label or shorthanded as a med. But in terms of the numbers and the calculations and conversion factors, we must establish, and I'm going to use my highlighter tool so we can go through the words, that we have a prescription. The doctor prescribed a particular dosage. So the prescribed dosage is 0.150 milligrams of our medication. So let's write that down. We have a prescription that is 0.150 milligrams of the medication. Additionally, we have another piece of information, which is the medicine that we have in hand. Particulars, we can see that we have tablets in stock that are going to contain 75 micrograms of the medication overall. So whenever we have a particular medication in stock, that is known specifically as our clinical factor. And as I just mentioned, this is the medicine on hand. Let's just write it down. Our clinical factor is that in one tablet, we have 75 micrograms of the medication. Whenever we're dealing with dosage problems, in other words, clinical problems, one of the first things that we must do, specifically if we're given a prescription of how much medication to give, and we have a clinical factor, meaning the medication that we have on hand, we need to determine, does the units of each of them match? When we look closer at this problem, we can see that the prescription is in milligrams, while the clinical factor is in micrograms. In order for us to proceed with this problem, we need to make them match. You can choose to take the prescription and match it to the clinical factor, or you can make the clinical factor match the prescription. I'm going to choose to take the prescription and match it to the unit of the clinical factor. That being said, that means that the first step that I have to do here is to convert 0.150 milligrams and convert it to the unit of microgram. Because we have prefixes, milli and micro, this is a metric to metric conversion. So far, we have learned different techniques. I'm going to utilize the number line method to illustrate this conversion, but you can use whatever makes sense to you. The dimensional analysis, equality, so on and so forth. So taking this into consideration, I'm going to be converting from milligrams 2 micrograms. Micrograms, when it comes to the number line, is this mu symbol right here. So let me just write that as a note. This is also MC. And in this conversion, since I am starting at milligrams, I can highlight that point. I'm going to start at milli. And then I'm going to move the decimal place to get to micro. So that means that my endpoint is here. I can see that if I start from this area and I need to end at this unit, I have to move that decimal point 1 time, 2 times, 3 times. So during my conversion, I need to take the value 0.150 and move that decimal point 1 time, 2 times, 3 times. So now it's going to be placed here. That changes my quantity to 150 micrograms. Now that I converted my prescription to the unit that I have in my clinical factor, I can utilize dimensional analysis to find out how many tablets are required for the prescribed medication. So in step 2, what I need to do is say, let me write down the prescription that the doctor recommended. 150 micrograms of med. My clinical factor is going to turn into my quality, in other words, my conversion factor. So I need to convert it not into a fraction. Taking that into consideration, because I need to cancel the units of micrograms of medication. In my equality, this side of my equality is what has micrograms of medication. So that's what I'm going to write in the bottom part of my fraction. 75 micrograms of medication. And in the top part, I'm going to write what it's equal to, 1 tablet. In terms of the units, micrograms of medication cancels with 1 micrograms of medication. So that means that when I take 150, multiply it by 1. So if I take 150, multiply it by 1, the result of that, I'm going to divide by 75. I find that for this prescribed medication, the patient is going to get 2 tablets. Let's explore one more type of clinical problem. The following clinical problem reads, give 4 tests at 50 milligrams per kilogram to a child that weighs 56 pounds. 4 tests is available in an oral suspension labeled 100 milligrams per milliliter, and we need to determine how many milliliters would the nurse administer per dose. We need to express this answer in 2 significant figures. So here, there's a little bit more information given, but let's identify what we have in hand. I'm going to highlight it so we can dissect what we are going to utilize. First, because it says that we're going to give 4 tasks at a particular amount, this means that that information that I highlighted in blue is going to be the prescription. And it could be expressed as prescribed and then gives you the amount, or like I said, the doctor's ordered. So here, because it says give the medication, which is Fortas, 50 milligrams per kilogram, that's going to be our prescription. The next information that we have here is the weight of our patient. Our patient specifically is a child, and the child weighs 56 pounds. Next, we have how much Fortas we have on hand. Specifically, we have Fortas as an oral suspension, meaning that this is a liquid form of medication. And that I highlighted in green is going to be our clinical factor. Let me finish labeling. This is our clinical factor. This is just the weight of our patient. When we have this 3 pieces of information in a problem, we must see that there's a lot of units, and at times these problems could be a little bit more difficult to dissect. But what I'm going to mention is that if you're giving a prescription, you have the weight of the patient and you have your clinical factor, this is how you target these problems. The first thing that you write down is how much does your patient weigh? And if that weight is not in kilo, change it to kilograms. So I'm going to write down the weight of my patient, 56 pounds. And since it's not in kilograms, I'm going to change it to kilograms. In order to change pounds per kilogram, pounds to kilograms, I'm going to utilize a conversion factor from table 2.7 that establishes that 1 kilogram equals 2.20 pounds. Since I'm trying to cancel the units of pounds, that means that 2.20 is in the denominator of my fraction. On the top, I'm going to put what it equals to, 1 kilograms. So by doing this, I already changed the weight of my patient into kilograms. In the next part of this dimensional analysis setup that I have, I'm going to utilize the prescription. I'm going to find out overall how much medication do I need to give my patient. Notice that it says 50 decimal place milligrams per kilogram. Another way to write that will be to say, well, every kilogram of weight for that patient is going to correspond to 50 milligrams of the medication that needs to be administered. So by writing it this way and canceling the units of kilograms, we are calculating for our patient how much medication we need to give the child. Lastly, you're going to use your clinical factor as your last conversion. Let me just take a few more notes. So next, we're going to use as a fraction our prescription. Next, we're going to use our clinical factor. And when we're using our clinical factor, we're trying to cancel the units of mg of medication. See that our suspension comes in mg of medication per milliliter. So what that means is that out of these two numbers, we need to diagonally cancel mg of medication. So our clinical factor is going to be used as a fraction by writing 100 milligrams of medication corresponds to 1 milliliter of the medication. When we do that, our milligrams of medication are going to cancel each other. And overall, to get the final answer, we are going to multiply 56 times 1 times 50 times 1, and we're going to get a result. We're going to be dividing that by the result of multiplying 2.20 times 1 times 100. When you put that into your calculator, you're going to see a large digit or a series of numbers that is your calculator display. You can see that in this problem, I wrote express your answer in 2 significant figures. So that means that from our calculator display, we must round. Rounding is implied. So when we take our calculator display and we round it to 2 significant figures, our result is 13 milliliters. To practice clinical factors, we are going to go to page 76 and do together problem A out of the textbook problems in 2.64. The problem reads, the physician has ordered 1.0 grams of tetracycline to be given every 6 hours to a patient. If your stock on hand is 500 milligram tablets, how many will you need for 1 day's treatment? For problem 2.64a, let's write down the information that is given. Tetracycline is our medication. The prescription meaning what the doctor ordered, is 1.0 grams of the medication. And you can see that there's a specific time is given every 6 hours. So that means that that is going to be per 6 hours. Then it says that specifically we have your stock, meaning your clinical factor, is specifically 1 tablet equals 500 milligrams of the medication. So with this, overall, the question wants to know, how many would you need for the whole day? So even though that this information that I wrote down is the given, what we need to find is tablets per day. So with this, let's set us the problem in terms of dimensional analysis. First, let's write our prescription. We need to give 1.0 grams of medication per 6 hours because it is every 6 hours. When I look closely at the problem, I can see that my medication and my clinical factor do not match in units. So before I proceed and set up all the other fractions in my dimensional analysis, I should match the units of the medication with the units of the clinical factor. So to do that, I can find out that in 1.0 grams, how many milligrams does that correspond to? I'm going to choose to find that information by utilizing the number line method. In this number line method, I'm going to start at my basic unit of gram because that's where it lives in the number line. So grams is right here, and I'm trying to convert it to milli. So I'm going from here to here. Using the number line method, I can see that my decimal place needs to be moved 1 time, 2 times, 3 times from left to right. So if I take the value of 1.0 and I move that decimal place 1 time, 2 times, 3 times, I can see that there's 2 pockets. I'm going to populate it with zeros. So 1.0 grams of the medication corresponds to 1,000 milligrams of the medication. So this means that the doctor is prescribing 1,000 milligrams of the medication for every 6 hours. So let me make the change in the units before I proceed. Next, this is the medication needed in 6 hours. But the question is asking tablets per day. So I can already find out how much medication is needed in a day by using the conversion that establishes what is the relationship between hours and days. Since I'm trying to cancel the units of hours, I need to place the unit of hours in the numerator of my fraction. From the conversions in table 2.7, we know that in 24 hours, there is 1 day. The units of hours cancel for this first part. Next, since now I know how much medication I will need per day based on the units that I've canceled, the next thing that I could do is set up the fraction that will allow me to find out how much medication overall the patient is going to receive. So, since I still have milligrams of medication and I have my clinical factor, if I place the 500 milligrams of med here, and that's in 1 tablet, I can cancel the units of milligrams of medication with milligrams of medication. And in this dimensional analysis, even though I've gone stepwise, if we take 1,000 multiplied by 24 times 1 and take that result and divide it by the multiplication of 6 times 1 times 500. Let me get my calculator. We see that overall, you will need for 1 day 8 tablets of the medication in 1 day. Make sure that you practice with the other book problems.